Assalamu alaikum students, how are you all? Hope you all are very fine children. And last session you have learnt about how to measure the thickness of a coin or cover page of your textbook and how to measure a curved path and measurement of area and units of measurement. Now in today's session you are going to learn about how to measure volume of irregular solids and volume of liquids and measuring an irregular plane surface and irregular surface also. So now let us enter into our lesson. Now let us see how to measure the area of a regular surface. For this you have to cut a cardboard into a shape of a rectangle having length 4 centimeter and 2 centimeter breadth as you are seeing here. Let us measure its area. The convenient unit to measure the area of given cardboard would be centimeter square. Take a centimeter graph paper. Each small square on this graph paper has a side equal to 1 centimeter. The area of each small square on this graph paper is 1 centimeter square. Now place the cardboard on the centimeter graph paper as you are seeing here in this figure 15 and draw its outline with the help of a sharp pencil. Now remove the cardboard and mark the shape as P, Q, R, S as you are seeing here. Count the number of squares inside the outline. The number of squares is 8. You can count here on the graph paper. Upper side 4 boxes are there and lower side 4 boxes. Total is 8 boxes, 8 squares. Area of cardboard is equal to the area covered by PQRS on the graph paper. Now we see area of PQRS is equal to total area of unit squares inside the PQRS. Now total area is we can say that 8 squares 8 into area of 1 unit square. If you see 1 unit square is 1 centimeter, we have already told. Now if we multiply 1 centimeter square with 8, we will get 8 centimeter square. In this case the cardboard we used has a regular shape, that is the shape of the cardboard is rectangular. Now can you relate the measured area to some formula of finding area? Can you relate it? Yes, it is length into breadth. Now children, let us see the measurement of irregular plane surface. Let us find out the area of a surface like a banana peel or a leaf. Now here you can see how to find the area of a leaf which has irregular shape. Now place the leaf on your graph paper as you are seeing here in figure 16. Mark the boundary of the piece of leaf on the graph paper with a pencil. Now remove the leaf to find the outline or boundary of the leaf on this graph paper. Now count the number of complete squares, each of 1 centimeter square area inside the boundary. Also count those squares inside the boundary which are half or greater than half. Add to the number of complete squares. This total number of squares inside the boundary gives the area of the leaf. If there are n squares inside the boundary, the area of the leaf becomes n centimeter square. Neglect those squares inside the boundary which are less than half. This process will give us the value of area which is close to the actual area. Now let us see measurement of volume of liquids. Now, how can you measure the volume of liquids like kerosene, milk? So, we use some measuring cylinders to measure the volumes of liquids such as kerosene, milk, oil, water, etc. Now, the volume of liquids we express in units like liters and milliliters. Liter is represented with a symbol L and milliliter is represented with ml. So now let us measure how this cylinder. It is cylindrical in shape with graduations marked on its body. Measuring cylinders are available in different sizes. They are used in laboratories to measure a certain volume of a liquid and to measure milk, oils, etc. by shopkeepers. We can fill it with the liquid to be measured and then read the marking at the lowest point of the concave surface of liquid. We must bring our eyes in line with the level of the liquid and then read it. Now let us see measuring a cardboard. Now you can look at this figure 18 and 19. Now let me explain. There are certain number of identical cubes of length and breadth and height 1 centimeter each. So what is the measurement of a cube here? So its breadth is 1 centimeter, its length is 1 centimeter and its height is also 1 centimeter. Now the length of cardboard box is 3 centimeter and its breadth is 2 centimeter and its height is 2 centimeter. Now place 3 cubes in a line so as to cover the entire length of the cardboard. Along the side of this line, place another line of 3 cubes so as to completely cover the surface of the box, cardboard box. How many cubes have you used so far? How many cubes do you need to cover the entire empty space in the box? Let us see. Place more cubes over this set of blocks so that the total space is occupied by the blocks. Now calculate the number of cubes occupying the rectangular cardboard box. How many cubes occupy the rectangular box? Can you guess the volume of rectangular box? Now let us see. Since each cube has measurement of 1 centimeter length, 1 centimeter breadth and 1 centimeter height, the volume of one cube is equal to 1 centimeter into 1 centimeter into 1 centimeter, that is 1 centimeter cube. We can write it as, which is known as 1 cubic centimeter, and we can write this as 1 centimeter cube. Cubic centimeter is a standard unit for measuring of volume of solids. Now, therefore, the volume of rectangular cardboard box seen here is equal to the total number of cubes occupying it. Therefore, the volume of rectangular cardboard box is equal to 12 into 1 centimeter cube. Now, our answer, our volume of rectangular box is 12 centimeter cube. However, if we multiply length, breadth and height, it would be 3 centimeter into 2 centimeter into 2 centimeter. That is 3 2s are 6 and 6 2s are 12. So 12 centimeter cube is the volume of our rectangular cardboard box. Therefore, we can say volume of box is equal to its length into breadth into height. So now let us see how to measure the volume of irregular solids using a measuring cylinder like you are seeing here. Take a measuring cylinder and fill almost half of it with water. Record the volume of water like you are seeing in figure 20. Let us assume it is a centimeter cube or a ml. Now tie a small irregular solid stone with a fine cotton thread. Put the solid gently into the water like you are seeing it, figure 20. Into the water in the cylinder so that it is completely immersed in water. What changes do you notice in the water level of the cylinder? You may notice that the level of water in the measuring cylinder rises as the stone that displaces water equal to its own volume. Now record the new volume of water. Let us assume that new volume of water is BML. Now the volume of a stone will be the difference between the second volume and the first volume. That is, volume of the stone is equal to B minus A centimeter cube. If we assume B as 80 and A as 60, then if we subtract 60 from 80, we will get 20 centimeter cube. Which gives the volume of the stone or difference between the second volume and first volume. Now children, we have completed our lesson. Let us measure. Now in our next session we will be starting a new lesson. So up to that, be happy. Allah Hafiz.